So for those of you who haven't worked with the streaming and real-time data, let's just quickly skim through some of the basics. So I quite like to use the metaphor of a river. So imagine you have a garden that you need to water. And so batch is just having a bucket and walking to the river and filling the bucket with the water, going back to water your flowers. Streaming is literally putting a pipe from the river to your flowers. It's processing data piece by piece as they arrive to your system. That's creating quite challenging sometimes and different approaches to very simple things like average. To calculate average on an offline data or a batch of data, it's very simple. But if you have a streaming scenario, when the data coming piece by piece, you have to do it slightly differently to get the average over the time or maybe a rolling window. So why I'm passionate about Quix and streaming in general? Well, me and my co-founders were connecting F1 cars to factory. So engineers can basically build decision insights that are real time, and they don't have to travel around the world every second week. The problem was that the amount of data was so great that we haven't found a database that will basically be able to persist and query this data at the same time. It was around 30 million values per car per minute. So this is where we basically get involved in the streaming tech. So about the ML, before we start and we do some demo. The offline training, which is the classical one, you basically use offline data, you label it, and at the end, you train it to get a picker file. That's not really important today. What is important is how you use that picker file, how you use that model in your production systems. Traditionally, you have an API deployment. You probably already saw this. This has some disadvantages. So if the amount of data is really high, you're losing a lot on CPU overhead of each API call. You also have problem if you have suddenly a lot of requests. Eventually, your microservice would get longer and longer to respond until it reaches a timeout, like 60 seconds or something. And at that moment, you have a downtime in your system. So you can always scale it by putting more instances, but you never can predict how many requests you're going to have tomorrow at 6 p.m. So what is our approach here? What we're going to do today, and how you can solve this with the streaming. So it's a combination of 3 pillars. The number one is we're going to use microservice architecture, where we're going to deploy Kubernetes containers to the cloud. And we're going to use the Kubernetes scalability framework together with Kafka scalability framework to build a horizontally scalable pipelines. We're also going to rely on Kafka, which gives us resilient features like persistence. So if we get downtime in our code, Kafka would basically help us with that, so we don't lose any requests, and also help us with the robustness and replications. A bit more about that later. And more importantly, a Python, because ML really lives in Python ecosystem, and I don't think it's fair to ask people to use Java when they building ML systems. So that's why we're going to use Python and Python only. So I want to talk about the most important concept to grasp today. It is what's sometimes being called pub and sub service. So the idea is that you have input topic when you have your input variables. That could be messages coming from a website, from external system, mobile application, doesn't really matter. Then you have in the middle your microservice, which is consuming this data, deserializing it into memory, and then you can do whatever you want in Python. You can call ML model, you can clean data, you can extract frames from video, you name it. And then you send the output to output topic. That's all. You don't care about how data gonna be consumed, your output gonna be consumed, how did it come to you, etc. So in this image, you see that the Kafka is on the left and right, and Kubernetes is in the middle. Well, why this is a good idea? Well, first of all, it's a very scalable solution. So on the left, that orange topic is actually created from 8, 16, 32 small topics called partitions. Those partitions are used to horizontally scale the data transport over the cluster in Kafka, so you can basically add more and more data while you're just adding more and more nodes. So there is no bottleneck in transportation. And those partitions then are assigned to multiple instances of same container running in Kubernetes. So idea is that if we have here 3 instances, as you can see here, imagine you have 9 partitions on the left. Each instance would have 3 partitions. And then the last magic point here, data being evenly redistributed over the partitions as you stream them to the input. So if you have 9 partitions and 90 streams, each partition will get roughly 10. So this is an idea how you can stream process data and horizontally scale it as you get more and more data. It is also very resilient and robust solution. Why? Well, first of all, Kafka allows you to set partitions replica, which means that you would send the same data twice or 3 times to different nodes in a cluster. So if you have a hardware failure, the stream processing is ensured. Also, in terms of compute, if you have a hardware failure in a compute cluster, in a Kubernetes, or possibly you just have a buggy code, Kubernetes will restart that container, and until that happens, the others will take the load of the requests. And finally, if you just haven't designed your system to cope with a number of requests that just happen at 7 p.m. when you have a spike, the worst thing that can happen with this system is just that responses would get a bit longer, but you will never miss a single request just by design of this architecture. Quite important if you're, for example, trying to mark a fraudulent transactions, for example. You don't want to lose them because of your downtime. So today, I want to show you how to apply this idea, this architecture, on a very simple application, which is a chat application. You have chats, rooms, where people can chat, and I will measure sentiment of these messages to get if the discussion is positive or negative. And then to show the scalability of the solution, I would connect Twitter to the system and analyze the sentiment on the Twitter. Tomorrow, I will also do the same thing on image recognition. So if you want, 3 p.m., the same place. So here's the Quix, which is a platform that the company I founded is building, and it's basically just trying to make everything we just discussed a bit easier. So I have here a super simple, quite rough front-end application that's running as a container, and sorry. I think it was not running properly. Cool, so it's running, and now I'm gonna use this application to send some messages. If the Wi-Fi, yeah, cool. So here I'm just gonna join a demo room as Tomas. And by the way, if you want, you can also use the QR code to join me in the conversation, but I think it's not necessary. But if I say hi, how are you? So imagine we have a chat like that. And this is not really doing anything right now, which is the purpose. The only thing that's happening is that sending messages to the WebSocket gateway to the Kafka, and then we're using the same gateway to receive the messages. So there's no added value really. But here's the thing. How we can now plug ML model to measure the sentiment of those messages real time. Oh, somebody really joined? Amazing. How we can measure this sentiment real time? Well, you remember the one-on-one slide with pop and sap? We're going to do exactly that. So here we have a web app gateway, which is now sending messages, as you can see here on the left. And if I send the message again here, it will give me the message here. There we are. So we have a messages from you in a topic. That's great. So now I'm going to click here a plus button. And this is an open source repository with all different templates, from a basic pop and sub service templates to quite a complex machine learning services. To show you how to build this, I'm going to use the smallest template we have. And here's a code of pop and sub service in Python. So if you want to use Python, this is the one to use. And it will pre-configure the repository completely to this infrastructure, so I don't have to do it. So I'm just going to give it a name. And I'm going to listen to topic called messages, and I'm going to output it to sentiment. There we are. So this will create a repository in Git, which I can clone locally and use IDE. But we don't have a time for that today. So I'm going to use this web-based IDE, which is now spinning up in Kubernetes with all the runtime we need for Python. So I want to drive your attention to this method and this method. You remember that slide with the gray middle service? This is where our business logic gonna be. So we get the input, we do something with it, and we send the output with that line of code. So the cool is that I'm just gonna press run, and it's just gonna work. It's not gonna do anything, but it's gonna give us a data. So these are the messages that we sent 5 minutes ago. You might be asking, why I'm seeing these messages? It happened 5 minutes ago. This is exactly where Kafka gives you the robustness. I had a downtime. Well, actually, I haven't done the service yet. But I have the messages in Kafka in case I need them. They will be there for 1 day or something. So now, let's just do something super, super easy. So I'm going to send a new row. So this is a tabular format that we have in SDK. And I'm just going to pass the timestamp. And in the tags, we have, for example, your name. So that's, again, not that important. But what is important is this column that I'm going to do now. Yeah. Can you hear me? No. And now? OK, so that doesn't work. Fine. So I'm going to add a column called chat message. And we're going to start with a super simple thing. And that's going to be your messages uppercase. OK? There we are. So I'm going to run this service now. And it's listening for the messages. And if I say here, hola, it's going uppercase. So we have done some processing. Very simple one. But you can see it's real time. And it's coming from the cloud. And this is basically the simplest thing you can imagine. So now, let's plug a Hugging Face model from Google in a similar fashion as we did the upper. And let's get the sentiment. So going back, stop this service. And here, I'm going to borrow for my notes. First of all, the library. This library is very powerful. It has all different models, and it's a pip package that I'm just gonna now install. It's about 1 gigabyte of data, but because this is all happening in the cloud, it should be quite fast, like 30 seconds. Then, I'm gonna use already built, already trained model. Obviously, if you don't want to use something already pre-trained, then it's on you to train the model, export it to pick a file, probably save it to some model registry, and then open it here in this code. But we're not gonna do that today. It's still installing. It's almost there. Cool. So now I'm gonna go to main PI, and here load the model into memory. This is very important. This is the basics. You load the model once to memory, and you just call it when you receive the data to get the output. And then I'm gonna pass it to the function that I create every time I get a new stream. What actually a stream means in our demo? Well, it's a chat room. So every room has its own stream. So that's how we scale this horizontally. So if you're gonna have 1,000 rooms, you're gonna have 1,000 streams. They are all on the different partitions, as you remember in our slides. So then I go to the function, and here I have another example that I'm gonna use here. So as you can see on the line 13, I just basically get the message from people, call this model, get this score, and send it to the output. So here I add the column. And that's it. We are done. So I press run. Now it would load the picker file, as you can see, for first time. There we are. And, oh, I forget something. So here we have to also add the from transformers, import pipeline. Cool. So let's try it again. And now, if I say here, hi, there we are. That's a positive message. So you see it's green. If I say it is ugly, it's negative message. So you see, we get a real-time sentiment of the messages that we see. Thank you very much. So now we're measuring the sentiment of each individual message, but we're not measuring yet the sentiment in the room. And this is where it's get a bit more complicated, where we have to do a stateful processing. We have to make our stream processing have some state. So you remember the average? So normally the average is quite a simple thing. But here, I'm gonna do sum So I'm gonna remember the sum and count of sentiment in that room, and here every time I get the score, I will just do this. So basically, I have all the information I need to calculate the average sentiment every time I get a new message. Cool. So now I can add a new column here, which we're gonna call average sentiment. And here I will do sum divided by count. So as you can see, I need to get both informations all the time to be able to calculate this. So let's do it. So as you can see, on the right, we now have the average sentiment in the room. So if you would now start sending something positive or negative, it will go up and down, up and down. There we are. So how we can use this for something real? Well, imagine that you want to buy or sell Bitcoin, and you want to know if it's a good time or bad time. Well, I have here the same demo in a different workspace where I have when I have connected a Twitter. So Twitter has very nice streaming API, and you can subscribe for certain hashtags and you get a stream of data. And then I have this little function which I'm gonna show you, which just convert the columns names to what we expect in the front-end application. No rocket science there. Which means if I go to this chat application and I go to the Bitcoin room, and I start the Twitter. If you do it at home, be careful. The Twitter for free gives you some quota, and because a lot of people talking about Bitcoin, you will run out in like an hour. So this is a connector we have in the library. You only have to code it. You just press a couple of buttons, you put your token, and it's there. So this is streaming. Very cool. And this is also working. You can see on the top all the monitoring, CPU. Amazing. And now we have all the messages from the Twitter talking about Bitcoin being analyzed. And you can see it's quite negative. Yeah, mostly red messages. And all of this is actually using less than half of the core. So this is how efficient the pipelines built in memory without server-side orchestration like Spark or others. And no Java, most importantly, will give you. So you save your money, you get better latency, and yeah, and you can do this. And now, obviously, it's up to you what you're going to do with this information. You can call API, integrate with Slack, Twitter, Twilio, you name it. So yeah, this is it. I hope it was clear and you enjoy it. If you want to do this at home, this is a QR code for a account where you should be able to basically replicate every step I did without any programming. So it's up to you where you want to, start testing stuff. But every service I show today is in that library, ready to go. You just need to get a Twitter dev token to do it. Thank you very much for coming here. And if you will be interested how this works with image processing, tomorrow at the same time, I will be here talking again. So if you have any questions, I'm here. Thank you.